going over the Unit 10.3 homework, last homework in the book, besides the review and test preparation, but this is the last lesson. Kind of interesting. I started writing this book and recording all these videos and creating all this material 9 years and 4 months ago. So tonight's video, and I just kind of wanted to celebrate on the air here, is the end of 9 years and 4 months of work. We'll get this finished up, take them home, and convert them to MPEG-4s on the home computer. And within a couple of days, a 9-year and 4-month project will be completed. I hope that this has really helped in your education. It's been quite a project. I've really enjoyed it. I did it really for my students, and hopefully others are benefiting from it now. Y equal x, we've got to go back in our minds all the way to page 96, where we discovered this, and then page 97, where we wrote a rule for it. Remember that y equal x is a special kind of line. Y equal 8, excuse me, is a special kind of line. I'm not going to tell you what kind. I've shown you enough. So you can go from there, page 96 and 97. X minus 2 quantity square plus y minus 4 quantity square is a circle. The rules for that are on page 267. What you're going to do is name the center. You're going to name the radius. And you're going to use the center and the radius to graph. Did you notice I'm not finishing any of these? I'm just trying to tell you what it is and where to find the notes, the specific things you're going to have to know to graph it, and I'm going to let you go from there. So on number 1, you can graph from there without any table. Number 2, you can graph from there without building a table. You're just going to use the center and the radius. Number 3 is a quadratic. We can find the vertex of the quadratic. We can find the line of symmetry of this quadratic just by looking. But that's not going to give us enough information to make a good graph. We learned how to make a nice, pretty table of points for a quadratic on page 195A. It's very detailed and specific. You will need to follow those instructions, build you a nice table of points to get a nice, pretty graph of the quadratic. Number 4 is rational. We learned about rational graphs on page 241. We know that it's rational because it's got it divided by x. And what you may remember is we're not just going to build a table, we're going to build a huge table. And if you want pretty numbers to kick out, then you could plug in this one things that are going to divide evenly. But remember when we did that, we chose some negatives like -3, -2, -1, 0, positives 1, 2, and 3. And you might recall that the graph, the parent function, looks something like that. And so we had to get a whole gob of points. So not only did we need some negatives and positives, we needed some negative fractions. and some positive fractions. Remember that? And so, excuse me, uh, get out of there. And so, sorry about that. I accidentally hit an email or something that popped up. I didn't even read it, so I don't. I saw NREA, National Rural Education Association, pop up. But anyway, okay. So remember, when we plug that in, we got a whole gob of points because our graph is um, gonna require lots of points to see where it's going. Okay. So then you can investigate that, page 241, if you need to get a view of that. Number 5 is an ellipse. We're going to have a square root 6 for a stretch, and I didn't pick very good numbers for you here, did I? And we're going to have a square root 3 for a stretch. And so you're going to probably have to go to your graphing calculator and estimate about what that is, which is fine. And so what you're going to do is you're going to tell me what the center is, and you're going to graph that center wherever it's located, and you're going to stretch out your x's by that much, either way from the center, and you're going to stretch out your y's by that much, either way from the center. It's going to turn into an ellipse. Okay? X only, again, page 96 and 97. No need for a table. We know what it is from memory. You just zip it in there. Number 7 is the square root. This came out of chapter 9, page 255. It's a radical graph. Remember that when you pick your x's, then we don't need a negative square root. So what's under that square root has to be greater than or equal to 0. So the least number we can choose for x is 6. And then when we choose x's, we'd like to get things like 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16 to get some pretty numbers. So to get a 1, you could put in a 7 because 7 minus 6 is 1. And to get a 4, you could put in a 10 because 10 minus 6 is 4. And so we're going to choose our points wisely. To get a square root graph, you really need to build a table there. We should have some idea of what the parent function looks like, and we should know that that's going to shift it up 5, shift it right 6, make it steeper quicker, and make it reflect. We should know that, but there again, we want to build a table and plot some points. This is an absolute value graph. We learned about absolute values in chapter 10, page 265. We know that the graph of an absolute value is a V. We know what these parameter changers are supposed to do. That's going to shift up 4, shift left 4, the opposite of a positive 2. It's going to make the V skinnier, and that's going to make the V face down. But we still need to build a table of XY values to see where that's going. Okay? And you can play with those X's until you get a nice pretty V. If you end up with a little check mark, you need some more points over here, right? Okay? All right. Play with that till you get a good little graph. All right, number 9 that with a plus would be a circle with something down here. We've got some stretching going on. And so that would turn it into an ellipse. But then there's a minus on the y. So our ellipse blew up and it turned it into a hyperbola. It's positive on the x. And so it's going to open on the x, something like this. And it will have a center, and it'll have some vertices, and it'll have some asymptotes. And it's not going to be right where I drew it, but you can look back to the lesson there, lesson 10.3, page 267, and study about that. Okay? And then number 10 is a plano y equal mx plus b, where m is the slope and b is the y-intercept. And you can see an example of this on page 97a. Okay? And I didn't do those for you because I want you to have to try to work your way through it. And so what I want you to do is go back and look at the examples, study those, watch the video on the lesson if you need to. Also, the review is the pretest practice and review, page 272 to 273 is videotaped in its entirety, and there's some more examples you can watch. So you've got plenty of video there, and so we're going to leave it like that so you'll have to dig this out on your own. Well, thank you for following along in the text here, and I hope this has helped you out a lot.